Okay, these are the answers to the orange workbook, page 123, where we're going to calculate molarity and parts per million. And we're going to do the calculations by going to our reference table T and specifically looking at concentration. Here are the formulas, parts per million and molarity. So let's go to question number 24. And it's going to ask, what is the molarity of KCl solution containing 116 grams of KF in 1 liter of solution? So we have to calculate molarity. And if we go to a reference table, we're going to see that molarity is moles of solute over liters of solution. So let's go ahead and do the work. So what do we say? Molarity is equal to moles of solute over liters of solution. If we go back to the question, we're going to see that they gave us 1 liter. So they gave us the value. So we're going to go back and write 1 liter. But they didn't give us moles. What did they give us? They gave us grams of KF. So our solute is KF. But they gave us grams. How many grams? 116 grams of KF. So they told us 116 grams of KF. What do I have to do? I have to change my grams to moles. Is there a formula that helps me calculate moles? If we go to our reference table T, the last one on our reference table, we're going to see moles is equal to mass over gram formula mass. So given mass, the mass that they gave us over the gram formula mass that we're going to calculate. So moles is equal to mass over GFM, given mass. Well, what mass did they give us? They gave us 116 grams of KF. We have to calculate the gram formula mass of KF. And we have K and F. If we look at the formula, we have 1 and 1. So we have, if we go on our periodic table, we're going to see that the mass of K is 39 and the mass of fluorine is 19. So 1 times 39 is 39, 1 times 19 is 19. The total is 58 grams per mole. So 58 grams per mole. When I divide 116 divided by 58, I get 2 moles. I got the moles. Where will the moles go? They're going to go over here. So 2 moles divided by 1 liter is 2 moles per liter, which is equal to molarity. What's moles per liter? Molarity or 2 molar. So we're going to go back to our question. And we are going to write that the answer is 2 molar. What is the molarity of a solution if it has 0.25 liters and contains 0.75 moles? So that's easy. What do we know? Molarity is equal to moles over liters. Well, how many moles do I have? That's an easy. It's 0.75. It's given to me over here. How many liters do I have? 0.25 liters. So 0.75 divided by 0.25 is giving me an answer of 3. And therefore the answer is 3 molar, and it is choice 3. Now this is a slightly different problem, number 26. They are asking for the moles needed to prepare 5 liters of a 2 molar solution. So they gave me the 2 molar. Whenever you see capital M, what did we say that it means? It means that molarity. So molarity is moles over liters. What's my molarity is 2, so I'm going to put it where the capital M is equal to moles. I'm looking for that. And how many liters do I have? 5 liters. How am I going to do this? I'm going to put 1 and I'm going to cross multiply. And I'm going to say moles is equal to 2 times 5. So therefore, I need 10 moles. Let's go to question number 27. What volume of a 2 molar solution is needed to provide a 0.5 moles of NaOH? We need a little bit more room here, so I'm going to write the answers over here. Let me just clear my previews. So we are doing problem number 27. And they gave me 2 molar. And they gave me 0.5 moles. And they're asking for liters. Molarity is equal to moles over liters. What molarity did they give me? 2 is equal to what? 0.5 moles over liters. You can write capital L or X. Just going to change the color. I'm going to cross multiply. So it's going to be 2x is equal to 0.5. Then I'm going to solve for x, and to solve for x, I have to leave x by itself. Because it's multiplied, I'm going to divide by 2. X is equal to 0.5 divided by 2 is equal to 0.25. 0.25 what? What is x? X is liters. 0.25 liters. So question number 27 is 0.25 liters. Number 28, what is the molarity of a solution that contains 40 grams of NaOH in 0.5 liters of a solution? So they're asking us for molarity, and molarity is equal to moles over liters. I have the liters as 0.5 liters, but I don't have moles, I have grams. So I have to calculate the moles by using the formula on table T. So we need a little bit more room, and we're going to go and work on a blank page. So we're doing question number 28, and we need moles, which is mass given. What mass was it given to us? 40 grams of NaOH. So I need the GFM. The GFM of NaOH, well, I have Na, O, and H. 1, 1, and 1 times 23 times 16 times 1, 1, 16, and 23. It's 40 grams per mole. So we're going to put the GFM 40 grams per mole. So 40 grams divided by 40 grams per mole is giving us 1 mole. Molarity is moles over liters. How many moles did I calculate to be? 1 mole. How many liters? Well, we had 0.5 liters. So 1 divided by 0.5 is a molarity of 2. Let's go back over here. So the answer is 2. Number 29. If 100 milliliters of 1 molar is evaporated to a volume of 25 milliliters, what will be the concentration of the resultant solution? Now, this is going to be slightly different problem. We're going to use a new formula that we haven't seen yet. So if we go to our reference table, we're going to see a formula called titration, and we're going to write also dilution over here. We're going to use this one later on when we study acids and bases, but for now it can be M1V1 equals M2V2. M stands for molarity, V stands for volume. So molarity for solution 1 times volume of solution 1 is equal to molarity of solution 2 times volume of solution 2. So let's go to our question. And let me clear so that we can see. So we're going to do question number 29. We need a little bit more room. So we're going to go to a blank page. So question number 29, we're going to use M1V1 equals M2V2. And they're telling us that I have 100 milliliters over 1 molar solution. So 1 molar solution, and I have 100 milliliters, is equal to, they're asking us for the concentration of the new solution if I have 25 milliliters. So I have to solve for M2, but it's multiplied by 25, so I have to get rid of it. So because it's multiplied, how do I get rid of the 25? I divide by 25 milliliters and divide by 25 milliliters. 25 milliliters and 25 milliliters cancel. Milliliters and milliliters cancel. 1 times 100 is 100. Divided by 25 is 4. So M2 is 4 molar. So let's clear over here. Let's go back to our question. And we're going to say that question number 29 is 4 molar. Now they're asking percent by mass, percent by mass. So these, we have seen it before. We're going to go to our reference table. Percent by mass. And we are going to write percent by mass equals part over whole times 100. So let's go to question number 30. We have a little bit more room over here so we can do the work over here. So number 30, they want you the percent by mass if 60 grams are dissolved in 100 grams of solution. So percent by mass is part over the whole thing times 100. What is the part? We have 60 grams dissolved in 100 grams total times 100, so it's 60%. Now, number 31 is slightly different because we see part over whole times 100. The part is 60 grams of acetic acid. Now the whole, it's 60 grams of acetic acid added to 90 grams of water. So the whole, it's not just 60 or 90, it's 60 plus 90 times 100. So it's 60 over 150 times 100, and the answer is 40%. Now you're going to say, why didn't I add over here? Because over here they told us 60 grams of NaOH are dissolved in enough water, sufficient water, to make 100 grams of solution. So the total solution, the total mass of the NaOH and the water is 100. Here, what did they tell us? You have 60 grams of acetic acid and 90 grams of water. So the total solution is 150 grams. Number 32. Calculate carbon dioxide has a solubility of 0.0972 in 100 grams of water at 40 degrees Celsius. expressed in parts per million. So ppm, if we go to our reference table, we're going to see ppm is mass of solute over mass of solution times a million. So let's go and let's write, what is the mass of your solute? Well, your solute is 0.0972 times a million over the total solution, which is 100 grams of water plus 0.0972 grams. And that is going to give me approximately 971 point something, and the closest one is 972 parts per million ppm. It says over here, to calculate, an aqueous solution has a mass of 490 grams and it contains 8.5 times 10 to the negative 3 grams of calcium ions. The concentration of calcium ions. So they want the concentration, but they don't tell us in units. But we're going to see the choices are in ppm. Therefore, we have to calculate the parts per million. The mass of the solute, the smallest part, is 8.5 times 10 to the negative 3. Times what? Times a million. And the solution is what? 490 over the solution. So the challenge is, how do you put this into your calculator? It's going to be 8.5, second E, it's going to appear as E, negative 3 times a million. Press enter and then divide by 490. And you are going to get 17 ppm. So practice putting the numbers in your calculator until you get 17 parts per million. Or it's going to be 17.3. So you're going to round to 17 parts per million. Number 34, what is the percent by mass? We're going to do again, percent by mass. So part over whole times 100. For KClO3, and you're going to see they didn't give us any numbers, but they told us it's saturated at 60 degrees Celsius. So we're going to go, so therefore we know in order for us to have a saturated solution, we know how many grams are dissolved by going on table G. So if we go to our table G, let's just clear our drawings and let's go to table G. Okay, so we have 60 degrees Celsius, right? And KClO3, so 60 degrees Celsius and KClO3. And our KClO3 is right here, okay? So we're gonna have to go across and find, it's gonna be approximately what, 38? No, I'm sorry, 28, 38. Okay, let's go back. So we're going to have 28 grams of KClO3 in 100 grams of water. So percent by mass is part over whole times 100. What is the part? Well, it's the 28 grams. What is the total solution? It's the salt and the water. So it's 100 plus 28 is 128 times 100. So when we do this math, 28 divided by 128 times 100, we get an answer of 21.8. Number 35, 2004 grams sample of an aqueous solution contains 0.012 grams of NH3. What is the concentration expressed in parts per million? So ppm is the mass of the solute, which is 0.012 times a million. Sorry. Over the solution. And what is the solution? 2400. So if we do 0.012 times a million, let me just fix this one. Divided by 2400, we get an answer of 5 parts per million. 36, the concentration of the solution is expressed in, we're going to see concentration of the solution. They're looking for units. If we ever forget, let's go to our table, T. Let's go back to our table, T. So we're going to see concentration. Let me just increase. Okay. So it can be either parts per million or molarity, or what's molarity? Moles over liters, or mass of solute times a million over mass of solution. So let's go back over here. The concentration of a solution can be moles per liters. Do we see that? Moles per liter. There's the concentration. ppm, molarity, moles over liter. So the answer to this one is moles per liter. Choice 2. The concentration can be expressed in parts per million, ppm, parts per million. And we can see that over here, parts per million, ppm. So number 37 is parts per million, and this is moles per liter, or molar or molarity. And that's the end of that page. I hope you enjoyed it. Thank you.